Relative maximums and relative minimums. Another important concept. And technically we say that a point C, f of C on the graph of f of x is called a relative maximum if f evaluated at C is greater than or equal to f evaluated at x for all of the x values that are in the immediate vicinity of x equal 3, x equals C rather. And we'll draw a picture of this in a minute to illustrate this. F of C is the largest value of the function within a reasonable distance of itself. In the immediate vicinity of x equal 3, in the immediate vicinity of x equals C, f evaluated at C is the largest value of the function. Now, what we really want to hone in on is the fact that the relative maximums are the peaks or high points of the graph. So wherever the graph comes to a peak, that's a relative maximum. Now, analogously, we define the point CF of C to be a relative minimum if f evaluated at C is less than or equal to f evaluated at x for all x values in the immediate vicinity of x equals C. Said differently, in the vicinity of x equals C, f of C is going to be the smallest value of the function. Now, what we really want to take from this is the idea that relative minimums are the valleys or the low points of the graph. We're after intuition here. So we want to have an intuitive idea of what a relative minimum is. And relative minimums are the valleys or the low points on the graph. Let's look at a picture or two. Okay, everybody, take a good look at this graph. Now, just a few minutes ago, we said that the relative maximums of a function were the high points on the graph. So here's a peak, a high point. Here's a peak, a high point. Here's a peak, a high point. These are all relative maximums. Now, we might have a problem with this. Somebody might say, well, you know, this point is higher on the graph than this one or this one. So why are these two relative maximums when this is the highest point on the graph? And here's the answer. When we say relative maximum, we're saying that this is a maximum relative to all of the points in the immediate vicinity. Relative to all of the other points close by, this is the highest point on the graph. Similarly, relative to all of the points close by to this point, this is the highest point on the graph. So that's why we have the expression relative maximum. It's a maximum relative to all of the other points that are close by. So relative maximum, relative maximum, relative maximum. And we'll label these. Relative max, absolutely. Relative max, absolutely. Relative max, definitely. Now, what about relative minimums? They'd be the low points or the valleys on the graph. Well, here's a low point. That's a relative minimum. Here's a low point. That's a relative minimum. And over here, here's a low point. Relative minimum. Relative to all of the other points in the immediate vicinity of this point, This is the lowest point. It's a relative minimum. Relative to all of the other points on the graph in the immediate vicinity of this point, this is the lowest point, relative minimum, and so on. So let's label these relative minimum, relative minimum, relative minimum. Now, let's see if we can milk this for all it's worth. In order for this point to be a high point on the graph has to change direction, right? Here the graph is increasing. Here the graph is decreasing. We have to have a change in direction here. So let's see. Here the function's increasing. Here it's decreasing. And what's the only way that we can have the graph change from increasing to decreasing right at this point? Isn't it the case that C1 has to be a critical number? Holy moly! Increasing, decreasing, critical number. And what about here? We have a relative minimum here. The function's decreasing here. It's increasing over here. The function changes from decreasing to increasing right at this point. That can only happen if the x value of this point, C2, is a critical number. Son of a gun. C2 has to be a critical number. I think we're getting to see the point. Any place that we have a relative maximum or a relative minimum, we have to have a critical number. If we don't have a critical number, we can't have a relative max or a relative min. So what about C3? Well, the graph changes from increasing to decreasing, doesn't it? And right where it changes from increasing to decreasing, we have the x value C3. It's got to be a critical number. And right here, C4, we got to have a critical number. And C5, the graph changes from increasing to decreasing. So right here where we have a relative max, C5 has to be a critical number. And C6, we have a relative minimum here, gotta be a critical number. This is a major revelation. The only place where we can have a maximum, a relative maximum or a relative minimum is where we have critical numbers. If we don't have a critical number, we can't have a relative max or a relative min. So let's beat that point to death now, because that's going to be a biggie. Okay, here's everything of importance in the next week encapsulated on one whiteboard. Critical numbers, increasing, decreasing functions, relative maximums and relative minimums. First of all, the critical numbers. An x value, x equals c, is a critical number of the function f of x exactly when either the derivative is 0, f prime of c is 0, and in this case, x equals c is a type A critical number, or the derivative f prime of c is undefined. In this case, x equals c is a type B critical number. Increasing and decreasing. If the derivative is positive, then f of x is increasing, going uphill from left to right. If the derivative is negative, f of x is decreasing. And remember the natural association: positive, increasing, negative, decreasing. Here's a biggie. F of x can only change from increasing to decreasing or vice versa at a critical number. If we don't have a critical number, the function can't change direction. It's either going to continue to increase or it's going to continue to decrease. But without a critical number, it can't change from increasing to decreasing or from decreasing to increasing. F prime, the derivative, can only change sign at a critical number. If we don't have any critical numbers, the derivative can't change sign from positive to negative or negative to positive. And finally, and this is going to be a biggie, relative maximums and relative minimums can only occur at critical numbers. And we're going to be looking for relative maximums and relative minimums. We're going to be looking for the high points and low points on a graph. If we're running a business, we want to know where the high point is on the graph of our profit function. And we want to know the x value that takes us to that high point. If we're running a business, we want to know where the low point is on our cost function. And we want to know the x value that puts us at that low point on the cost function. This is the kind of thing that we're going to be doing. And this is why relative maximums and relative minimums are important. What's right here is something that we need to know. I don't like to memorize a lot of things, but if we know what's on this board, everything that we do for the next week will follow from what's on the board here. All we have to do is just practice applying what's right here.